So the question is, let A1, A2 up to AN be a given AP whose common difference is an integer and sum of n is equal to A1 plus A2 plus up to AN. So if A1 is equal to 1, then AN is equal to 300 and n is equal to or greater than 15 and less than or equal to 50. Then we have to calculate the ordered pair, which is S n minus 4 and A n minus 4. So now let's move to the solution. So this is the solution. These values are given. A1 is equal to 1, An is equal to 300 and the value of n should be between 15 and 20, 50, 15 and 50. Now we know that the integer is a common difference between the series. So we would apply the formula and then after putting all these values you would get n minus 1 is equals 299 upon d. So it was mentioned in the question that d was an integer, so it has to be an integer, so which means that it should be clearly divisible by 299, and there are two values only, 23 and 13, which can directly divide 299. So we would take both these values, check both these values, so which one is true. So if we will put d is equal to 23, then after putting this equation we would get n is equal to 14, which is not true because it is mentioned that n should be between 15 and 50. So now we will take 13 and then the value will be come out to be 24, which is perfectly fine as per the condition. Now we had to calculate the ordered pair for S, which was n minus 4. So n is 24, 24 minus 4 is 20. Then we will calculate this value, we would get 2490, and after solve similarly we would solve for this, we would get 248. So the answer ordered pair is 2490, 248, which is the option 4.